In this lecture, we'll be doing problem solving using direct translation. A general strategy that we want to follow is to first understand the problem. This may involve reading it multiple times, drawing a picture, getting thoughts organized on the side, identifying where variables are needed, etc. Oftentimes, students make mistakes because they're in such a hurry to write the equation. Make sure you take the time to organize your thoughts and the givens from the problem. Then we want to translate the problem into an equation, solve the equation for the defined variable, and then check and interpret our solution. Make sure that we've actually answered the question that they've asked for. Our first example is 3 times the difference of a number and 5 is the same as twice the number decreased by 3. Earlier in this course, we looked at words that meant mathematical operations. We have many happening here. What I suggest when the problem's so long is find the word that means equals. In this example, the word is means equals. Everything that comes before this word in the sentence will be the left side of the equation. Everything after that word in the sentence will be the right side of the equation. So let's just look at the first piece. 3 times the difference of a number and 5. The difference means that we need to perform the subtraction of the number and 5 first. To indicate that that's going to be done first, we're going to put parentheses around that. So when we write the left side, we're going to have 3 parentheses x minus 5, 3 times the difference. Looking at the words after the is, we have twice the number decreased by 3. To write twice the number, that's 2 times x minus 3. Now we have an equation to solve. The first thing we want to do is eliminate our parentheses by distributing. 3 times x is 3x. 3 times minus 5 is minus 15. We have no fractions to eliminate, no like terms to combine. Let's get our variable terms on one side and our constant terms on the opposite side. I'm going to subtract 2x from both sides, leaving me with x minus 15 is equal to negative 3. Now that all of my variable terms are collected on the left-hand side, my constant terms need to move to the right. So we'll add 15 to both sides. This gives me x is equal to 12. Now we want to go back and reread our question to make sure that we've answered it. They're asking us to find the number. What did x represent for us? Well, it represented the number. X equals 12 is our solution. In the next example, we can see that a little bit more of a story is being told. An 18-foot wire is to be cut so that the longer piece is 5 times longer than the shorter piece. Find the length of each piece. I would start by drawing a picture. I have a wire. It's 18 feet in length, and it's been cut into a short piece and a long piece. Right there. Now we know that the short piece, together with the long piece, is the total wire. So we can make a general equation with just words saying that the short piece plus the long piece is equal to the total length of the wire, which was 18 feet. They give us a little bit more information about the short and long piece. The longer piece is 5 times as long as the shorter piece. Oh, what's the shorter piece? We don't know. That's our unknown. That's where our variable goes. The long piece is 5 times longer than the short piece. So that's going to be represented by 5x. Since x was the short piece, 5 times that, 5x. Now we're going to take those and plug it into this general equation that we wrote out, and we'll have the equation we need to solve. The short piece, x, plus the long piece, 5x, equals the total length of the wire, 18. To solve this equation, we'll start by combining like terms. 6x is equal to 18. All of our variables are already on one side and our constant terms on the other side. We will get rid of our coefficient of x by dividing both sides by 6. We end up with x is equal to 3. We want to go back and reread the question, make sure that we're actually answering the question. They're asking us to find the length of each piece, so we should have an answer for the short piece and the long piece. We used x to represent the short piece. We solved for x. That would mean then that the short piece is 3 feet. Don't forget your unit of feet. The long piece is 5 times x. So we want to take 5, multiply it by the value we found for x. The long piece is 15 feet. In Cleveland, the taxi cost is $3 plus 80 cents per mile. If you travel from the airport, there's an additional $4.50 toll charge. How far can you travel from the airport by taxi for $27.50? So there's kind of a lot going on here. We want to look at all of the pieces and try to come up with a general equation first. Now, the total charge includes $3 just for getting in the taxi, plus 80 cents per mile. That's what we don't know, the number of miles that were traveled. That's what they ask us to find later in the problem. How far can you travel? So the number of miles is our unknown. 80 cents per mile means 80 cents times every mile. So this will be the number of miles times price per mile, which we can go ahead and write the 80 cents right in there. We want to make sure to write 80 cents as a decimal because all of the other amounts in this problem were given dollars, so we want to keep that unit of dollars. And then lastly, there's a $4.50 charge, toll charge. So that needs to be included in our equation. Now that we have a general equation, we just need to fill in all the numbers that were given. The total charge is $27.50 equals the flat charge, which was $3, plus 80 cents per mile, plus a toll charge of $4.50. Now we have an equation that we can solve for. Notice that we have like terms on the right side to combine. $27.50 is equal to $7.50 plus 0.80x. All of my variable terms are already collected on the right side, therefore my constant terms must move to the left. I'm going to subtract 7.50 from both sides. That gives us 20 is equal to 0.80x. The last thing we need to do to solve for x is divide by its coefficient. We end up with 25 is equal to x. We want to go back, reread the problem, make sure we've answered the question. The question is, how far can we travel from the airport for $27.50? X represented the number of miles we've solved for x, so our answer is you can travel 25 miles for $27.50. Bill has twice as much money as Bob. Paul has $12 more than Bill. Together they have $92. How much money does each man have? Again, I like to start with a general equation. Together they have $92. So the amount of money that each man has added together gives us $92. So we can say Bill plus Bob plus Paul equals $92. We don't know exactly how much money each of these men have. So over on the side, I'm going to organize my expressions and variables for Bill, Bob, and Paul. The first sentence says that Bill has twice as much money as Bob. Well, how much money does Bob have? We don't know. So that'll be our variable x. Bill has twice that much, so we say that Bill has 2x. Paul has $12 more than Bill, so I need to add 12 to whatever Bill was. Bill is 2x, so Paul is 2x plus 12. Now that I have specifics about each of the guys, I can plug it into my general equation. 2x plus x plus 2x plus 12 equals 92. I have like terms on the left side that I can combine. It's going to give me 5x plus 12 equals 92. All of my variable terms are collected on the left side of the equation. Therefore, my constant terms have to move to the right. I'm going to subtract 12 from both sides. Gives me 5x is equal to 80. Last move to solve is to divide by my coefficient. We get x to be equal to 16. We want to go back, reread our question, make sure we've answered the question. They asked us, how much money does each man have? Right now, all we've done is solve for x, and x represents the amount of money that Bob had, so we know that Bob has $16. We want to plug that value for x into each of these other two expressions and solve. Bill has 2 times x, which is $32. And then Paul, he has 2 times 16 plus $12 to give $44. Here's our solution.